It's kind of easy to forget just how much computation is happening all around us, every single second. It's on a scale that's almost impossible to imagine. But today, we're not just talking about fast. We're talking about a whole new league of computing, one that's about to change, well, pretty much everything.
Just look at this number for a second. That's a 1 with 18 zeros after it, 1 quintillion. And that number, that is how many calculations a brand new type of machine can crunch through every single second.
Yep, welcome to the exascale era. This is a new frontier in computing power, and it's so immense that it lets us tackle problems that, honestly, we thought were impossible. We're talking about building a digital twin of our entire planet, or discovering new life-saving drugs from the ground up.
And for the very first time, a machine with this kind of power has landed right in Europe. So in this explainer, we're going deep inside Jupiter, a supercomputer that is absolutely set to revolutionize science as we know it.
So what is it that makes this machine so special? Let's get right into it and see exactly where Jupiter fits on the global stage. All right, so Jupiter's home is the Jülich Supercomputing Center in Germany. Once it fires up in June 2025, it's not just going to be the fastest in Europe, it's on track to be the 4th fastest in the entire world. But get this, what's maybe even more impressive is how it's built. It's also the most energy-efficient machine in the top 5. It's so efficient, it actually uses its own waste heat to help warm the buildings on campus. How cool is that?
Now, as you can probably guess, something this huge doesn't exactly come cheap. We're talking about a total investment of €500 million. Let that sink in. This isn't just another computer. It's a massive bet on the future of European science and technology. Okay, but how in the world does a machine like this actually work? What's the secret sauce? What's the engine driving this whole revolution? Well, to figure that out, we've got to zoom in, way in, from the giant computer hall all the way down to a tiny little chip.
Because here's the thing, Jupiter's incredible power doesn't come from one single giant brain. Nope, it comes from an entire army of tiny, unbelievably advanced engines all working together.
See, Jupiter isn't just one thing. It's a massive network of around 24,000 individual units. Each one is a little marvel of engineering called a superchip. And it's this clever, modular design that lets it scale up to these mind-boggling speeds.
And there it is. This is the NVIDIA GH200 Grace Hopper Superchip. This little thing right here, this is the heart of Jupiter, the fundamental building block. You get thousands of these working in perfect harmony, and that is where exascale power comes from.
Now here is where it gets really clever. The GH200 isn't just one type of processor. It actually fuses 2 different kinds together on the same chip. You've got the CPU, think of that as the brilliant calculating strategist. And then you've got the GPU, which is just the raw, number-crunching powerhouse. So a CPU, with its few powerful cores, is amazing at complex, step-by-step logic, like a general figuring out a really tricky battle plan. A GPU, on the other hand, with its thousands of smaller cores, is a master at doing tons of simple things all at the same time, like a whole army of soldiers firing at once. Putting them together is the key, but for a long time, it also created one giant problem.
And that problem? Well, it all comes down to memory, and solving it is probably the single biggest innovation inside this superchip.
You see, in the old days, the CPU and the GPU each had their own separate memory. This meant that to get anything done, they had to constantly copy huge amounts of data back and forth. It was a massive, massive bottleneck. Imagine 2 world-class chefs trying to cook a meal together, but they're in totally separate kitchens. They'd spend all their time just running ingredients between rooms. It was just so inefficient.
The solution is this incredible technology called NVLink C2C, and this is the real game changer. It's basically a superhighway for data that connects the CPU and GPU directly, letting them share information at 900 gigabytes per second. To put that in perspective, that is 7 times faster than the old standard. So, what does this actually mean? Well, with NVLink, our strategist and our powerhouse, they can now access the exact same pool of memory, instantly. There's no more slow copying. It's like we finally put those 2 brilliant chefs in the same kitchen, with one big pantry they can both use. Suddenly, everything is faster, way more efficient, and it just unlocks a level of performance that wasn't possible before. Okay, so we've got this amazing piece of technology, a true breakthrough. But so what? Why does it matter? What can we actually do with all this power? And this, right here, is where things get really, really exciting. Jupiter is being pointed squarely at some of the biggest challenges humanity faces. This kind of power lets us ask way bigger questions. We can build super high-res climate models to truly understand our planet, we can simulate the birth of galaxies to understand our universe, and we can even design new medicines atom by atom to cure diseases. And of course, it's going to be a powerhouse for training the next generation of artificial intelligence.
Let's make that more concrete. Think about weather forecasting. With Jupiter's power, scientists can run simulations that are so detailed they can, and this is a quote from the Research Center, significantly improve predictions of local extreme weather events. You know, this isn't about whether you need an umbrella tomorrow. This is about saving lives by giving us better warnings for major floods, hurricanes, and storms.
And what about AI? I mean, think about this. Training one of the huge advanced AI models we hear about all the time, that used to take months of nonstop computing. With a machine like Jupiter, you can do that same task in less than a week. That just dramatically speeds up the entire pace of AI research. It's a total game changer.
So, when you put it all together, it's pretty clear that Jupiter isn't just another faster computer. It really does feel like the start of something new. Because by building and owning a machine of this caliber, Europe is making a statement. It's ensuring that its scientists and innovators have independent access to the absolute best computational tools on the planet. This is way bigger than just science. This is a cornerstone of Europe's technological independence in an increasingly digital world.
Now, all of this leaves us with a pretty deep question to think about. We're now at a point where we can build machines that can simulate our own reality with incredible accuracy. So as we stand here at the dawn of this new computational age, maybe the most important question we can ask is, which problems are we going to point these incredible machines at, and what kind of future will we choose to build with them?
Thanks for joining us for this explainer. We'll see you next time.